I'm going to show you a demo how to use the bin, which is a software defects fault localization tool. To begin with, bin provides you two options where you can create a new debugging project or open an existing project. This is a fresh version, so I start with a new debugging project. I will be showing you a demo using a version 2 file, so the project name can be v2. The main information is over here. The input for bin is always going to be the ACTS file, which includes the initial input test set with its results, parameters, constraints from the previous phase, which is the X. So I'm using the .info file. In .info, I'm using the second version of total info file. So select the input file. So since it's a debugging tool, we need to provide the source code as well, so that this application can show you the execution trace along with the ranking of the faulty statement. So I select the source code file. In my case, it's in the same folder as the input file. You can choose if it is available somewhere else. Version 2. It's a C file, and this is I just indicate in case if I want to save the results where I need to know what is the file name it should be saved under. So I create it now. So a file is being created. So this is a basic master file which gives a basic information about this whole debugging project. What is the project name, which we have provided all these locations from where the source code is from, where the initial test set file is from, and the expected recommended test set and suspicious combinations, saving locations. Over here you can see the whole source code being displayed to the user, and this is this information is generated from the input file which we have provided. So in our case, we have an input file with parameters, tables, row, column, table attribute, comment, and max line, and each parameter has for instance, table has a parameter value of 0, 1, 2, whereas table attribute is having a value of parameter value of 0, 1, 2, 3 up to 5. So for this project there is no constraints, and these are all the initial test sets and the results of the initial test set. So for us, we have 156 initial test sets along with it pass or fail results. So let's begin the phase 1. In phase 1, phase 1 generates suspicious combinations, components, and recommended test sets. How this is being generated is based on the information from the initial test set with pass and fail. So let me show the initial phase 1. Now the phase 1 is the background algorithm is run and the phase 1 is output is ready. In phase 1, the system provides you the suspicious combinations. What it means is, out of these parameters, this combination seems to be the more suspicious one, or these combinations are the possibly the highly inducing combination which can result in a bug. So this over here, it shows you the ranking of suspicious combinations of parameters. Over here we have the suspicious component. So whenever this parameter table underscore attribute has a value of parameter 5, the ranking is very high. So this provides information based on the suspicious of individual component, whereas a combination provides you suspicious combinations provides you information about the inducing for the combination of parameters. So here we have recommended test cases. This is being suggested by the algorithm, and this expect as the tester to run the program for this input values and update the result section. So by doing so, it will help the algorithm to narrow down on the most suspicious component. So I have already executed this algorithm and I have the results with me. I have already executed this test cases and I have the results with me, based on which first is pass, second is This combination also passed. If I remember correctly, this combination failed. There was one more combination which failed. Aha, this is the one which was failed. Rest everything is pass. So I see the system. So once I update all the list recommended tested results, I can proceed to next iteration. So do you want to continue to next iteration? If I continue, so iteration 2 is also completed. So again, at each iteration under phase 1 is going to display the user the suspicious combinations, suspicious component, and recommended test set. So again, I have already executed these recommended test cases, so I knew the result upfront. If you have not done it, we need to execute our program, in our case tot_info.c file with parameters with these values, and find out the results and update the results. And remember correctly, this combination failed. This combination failed. This combination failed. Rest pass. Yeah. So since I updated it, I can proceed to next iteration. Over here, a user is given option. He wants to, if the user wants to go to next iteration, they can do so by pressing the S button. If they feel like this suspicious combination is enough, they can stop over here at any iteration and proceed to phase 2, which involves identifying core and derived members and arriving at the faulty rank statement. So I prefer to continue, so I press an yes. But the algorithm found out this, it has found out it has reached a point where it has found the maximum inducing combination, so it says it cannot proceed further. So let's click OK. It's going to show me these are the top 10 inducing combinations based on the results provided by us. So you can pick any one of the top 10 combination which you might consider faulty and proceed to next level. Next phase. So here I pick the topmost suspicious combination value, and I decided to continue to phase 2. So this is done, so I get a confirmation. This is the inducing combination that's being selected by me. Click OK, then I want to continue to phase 2. I click on this. In phase 2, we are going to have a core member as well as a set of derived members. So how this works is, in core member is nothing but a test set which will have the value matching the inducing combination. So over here, table is 1, row 0, table attribute is 5, comment is 4. So if you see, I can move the screen a little bit. So table is 1, row is 0, so you can see row is 0. Add table attribute parameter value of 5, you can see over here, comment value of 4. So this is predominantly maintained over here. So, and how I will explain you how the derived members and its sets are being created by the Ben. So to begin with, I remember I have already executed this scenario. I knew it's a fail. So let's go to derived member. So how derived member works is, in inducing combination, we can notice there are 4 parameters, and each parameter can have different values. So what do we do is, since this combination of values appeared in the core member, to begin with, in set 1, if you notice, table is equal to 1. So what do they do is, they keep the remaining values from core member as same, 0, 0, 5, 4, 0, 0, 5, 4, 0. Whereas table, if you see the parameters, the tables as the domain of table parameter is 0, 1, 2, and value of 1 is already figured in core member. So the remaining values for parameter table is 0 and 2. So we replace the value of 1 for the parameter table with other alternate values 0 and 2, and we try to find out whether this scenario pass or fail. In our example, these two already passed, I'd like to reiterate, I already executed this scenario, so I know the result up hand. If you're doing it for the first time, we need to run these results and update it over here. Let's go to set 2. So what's in set? It should be row. So if you notice here, only the parameter row has a different values. If I can cross check with the row, again row domain size of row is again 3 with 0, 1, 2. Row of 0 is already appearing core member. So in derived members 1 and 2, the remaining 2 values of row is being tested. And I have tried this scenario as well, and both the scenarios failed. Let's go to set 3. Here, from looking at the table, and from our previous discussion, we can figure out tables, row, column, comment, and max line all has the same value, whereas this column, table attribute, has a different value. So we can easily conclude that a table attribute domain size should be 1, 2, 3, 4, 5. The domain size should be 6 because 5 is already appeared over here. So the remaining 0 to 4 is being appeared over here. So I executed this. I'm sorry, as usual, all 5 has been passed. And finally, let's go to final domain set, which is in command. And I knew this is fail and rest of the things pass. So when we execute these test cases in phase 2, we need to capture the execution trace of the program. The reason why do we do this is because at the end of this algorithm, we are going to uh, rank the statements. So to rank the statements, we need to compare the execution traces between the pass test case and fail test case, and we can arrive at a conclusion based on our observation from a pass test case execution trace and a failure test case execution trace. So I have those execution trace in handy, so I'm just going to upload it. Okay, desktop, I have, come on, it's going on my Mac. Yeah, it's all fine. So if I go here, I already executed it. So I have arranged them in the test case numbers. So for first test case, 0 is the execution trace. So if you want to see the trace, I could see here. So this window shows me the execution trace, and it shows the line number 1 are the ones which is highlighted in green, indicate these lines are being executed for this test scenario. So it gives us a clear idea what goes on. Similarly, we will go ahead and quickly update all the remaining 12 test cases execution trace. Upload. I would like to remind you that I have already executed and we have already captured the test results, and we know the naming conventions. That's why I'm randomly picking up pictures. I knew this test case belongs to this one. Fifth one. Yeah, I know this is a time consuming process, but our tool is in the initial days, so we have to do system one by one. Probably in future we might come up with Dropbox kind of facility where you select all the files and put it across. It can take automatically and sort it. So I have uploaded 5, 6, should be 7. So I have uploaded all the test case execution trace of all the test cases as well as the results. So let's go ahead and see what is a faulty statement, high possible faulty statement. Oh, now it's ready. So here you see in this faulty statement you get a rank, a line number, and the source code which you're using. And if you scroll down, aha, this is the line of code which is highly faulty based on the test case results and the execution trace provided by us. So here if we rank the statements based on their values, suspiciousness values, so we have here we have four possible. There are certain statement which is, these are the highly suspicious statement or faulty statement I should say. These are the next highest statements. This may be the next, and these are the least. So that's how this is how our tool help us identify the possible or the potential I should say potential faulty statement in a program. I hope you enjoy the demo. Thank you for viewing.